one was truly prepared for what Tesla just unveiled. For years, lithium-ion batteries dominated the electric car landscape, setting limits on range, charging speed, and durability. But all that seems a thing of the past, now that Elon Musk has unveiled the long-awaited 2026 aluminum-ion battery. The promise of surpassing all technical pillars at once would be enough to cause a stir. But what's most impressive is the fact that this battery doesn't try to improve on what already exists. It completely changes the rules of the game. It's not just lighter, faster, or cheaper. It's a quiet, three-pronged revolution that starts with absurd range. With an energy density greater than 1,129 Wh per liter, the battery is capable of delivering more than 300 kilometers of real autonomy with a compact 55 kW pack. This means a car like the Model 5 can drive from Los Angeles to Seattle on a single charge, without any tricks or ideal laboratory conditions. The magic happens thanks to Anodus ultra-thin bilayer graphene, which replace conventional components and virtually eliminate internal resistance. This detail, almost invisible to the non-engineer, is what unlocks the vehicle's raw range potential without increasing its size or weight. And when we talk about near-zero internal resistance, we're entering a new era of electrical efficiency. At every centimeter of the cell, losses due to heat or dissipation are virtually eliminated. Sounds like a small thing? In practice, this means dozens of kilometers of range, which previously evaporated as heat, are now fully utilized. For the average user, this means fewer trips to the charger, less range anxiety, and more freedom when hitting the road. A battery that not only delivers more, but also wastes less. But autonomy isn't the only advantage of this new system. Tesla has included an innovation called DSPC, Dynamic Self-Balancing Power Clusters, something that seems straight out of a science fiction movie, but which functions like an energy brain inside the battery. Instead of activating all cells simultaneously, the system divides the battery into autonomous microclusters that work according to the actual needs of the moment. Going for a walk around the block? Only 2 clusters are activated. Going to tackle a mountain range? All come into action gradually and in a coordinated manner. This consumption intelligence has profound impacts. First, it reduces internal stress on the cells, which naturally extends battery life. Second, it saves energy by not wasting power in situations that don't require as much power. Third, it allows the battery to adapt to the terrain, driving style, and even the route's elevation, all based on an algorithm derived from Tesla's own neural network. We're talking about an autonomous, almost living, energetic organism that understands the context and responds in real time. And it doesn't stop there. The same DSPC system is capable of handling internal failures almost imperceptibly. If one of the clusters experiences any kind of degradation or instability, power redistribution occurs instantly, without the driver noticing any loss of performance. It's like flying a multi-engine aircraft, where you only operate the engines you need, and if one fails, the others take over. This approach not only improves system resilience, but also prevents minor issues from becoming major headaches. Another fascinating aspect is how this battery interacts with the car's other systems. Integration with the adaptive suspension and regenerative braking creates an unprecedented harmony between power, control, and economy. Energy generated during braking, for example, can be strategically redirected to specific clusters, balancing the internal load without overloading vulnerable parts. The car becomes a closed ecosystem of efficiency, where nothing is wasted and everything is utilized to its fullest. And to close this initial dive into this super battery, it's worth mentioning the true essence of this revolution: a single product that delivers more autonomy, more intelligence, and more longevity simultaneously. Unlike other batteries that sacrifice one benefit to gain another, Tesla has created a three-pronged balance that changes what's expected of an electric vehicle. It's not just about breaking records. but about offering an experience that redefines the very concept of electric mobility. While the new battery's autonomy and intelligence are already impressive, its durability promises to be the factor that will completely destabilize the global market. The promise of 15,000 full charge cycles may seem like a technical number without much impact at first glance, but when you do the math, that amounts to more than 6 million kilometers of useful life. It's as if a single car could make round trips to the moon multiple times without ever needing to replace its battery. And most amazingly, all this without relying on active thermal systems or complex mechanisms to maintain the internal integrity of the cells. The secret behind this robustness lies in two innovations that work together like invisible armor. The first is solid reinforcement structure at the edges, which prevents the growth of dendrites, those sharp microstructures that slowly corrode traditional lithium batteries from the inside. The second is a set of self-regulating thermal layers capable of maintaining a stable temperature even under extreme heat or cold. The result is a system that works reliably between 45 degrees Celsius, 65 degrees, without the need for liquid cooling or active insulation. This represents a dramatic change, especially for those living in regions where the climate challenges conventional technology. In freezing environments, where standard batteries lose efficiency, Tesla's new aluminum-ion cell continues to operate consistently. In scorching deserts, where heat degrades the internal chemistry of lithium-ion batteries, it simply keeps working. The confidence that the car will start, run, and deliver what it promises in any weather condition becomes a liberating factor, especially for drivers who rely on their vehicles for daily use. Another game-changing point is the passive degradation rate of this battery. While a standard lithium battery can lose up to 20% of its charge just by being parked for a few months, the aluminum-ion version loses a measly 0% per month. This means that a car parked in the garage for 90 days will start with virtually the same charge it had when it was turned off. This detail may seem small, but for those who travel, own more than one vehicle, or simply need to rely on their car after long periods of disuse, it makes a huge difference. And when we talk about longevity, it's not just the battery's physical resistance that counts, but also its ability to maintain performance over time. Many batteries, even after 2 or 3 years of use, begin to show significant drops in range and charging time. In Tesla's case, initial tests indicate that even after more than 10 years of heavy use, the drop in performance is nothing more than 5%, keeping the vehicle virtually as good as new. This isn't just about increased durability, it's redefining the concept of aging in electric vehicles. In addition to the obvious savings on maintenance and component replacement, this stability creates something unprecedented: long-term cost predictability. Drivers will no longer need to calculate how long their car will last before the battery needs replacing, nor worry about unexpected $10,000 bills for a new battery pack. This is especially important for low-income families, fleet owners, ride-hailing drivers, and anyone who sees a car not as a luxury, but as a tool for work or survival. Another powerful reflection is in the used car market. A battery that doesn't degrade like others completely transforms the perceived value of an electric car with years of use. Vehicles with 200,000 or 300,000 kilometers on the clock can be resold with complete confidence and virtually intact performance. What was once a weak point, the fear of battery life, becomes a selling point. Tesla can, without exaggeration, end the stigma of the disposable electric car. And it is precisely this new standard of trust, combined with the autonomy and intelligence already discussed, that forms the tripod of this revolution. The idea that a single electric vehicle can last for decades, withstand extreme climates, maintain its autonomy, and still take care of its own health internally. It seems exaggerated, until it works. And in this new scenario, what was once just innovation becomes the new normal. While the world watched Tesla's moves in Nevada and Texas from afar, Something completely under the radar was quietly being prepared in an unlikely place: Alaska. It was there, amidst the extreme cold and inhospitable landscapes, that Elon Musk decided to build the factory dubbed Cold Forge. One at first glance, it seemed like an eccentric, perhaps even absurd, choice. But behind this decision lies a strategic move that promises to turn the planet's battery production game upside down. By using the environment as an ally, Tesla has reduced energy costs by more than 70%, and the impact is devastating for its competitors, especially China. The secret lies in the forging process of the new aluminum-ion cells, which requires rapid and continuous cooling during the molecular compression stage. In places like Shanghai and Shenzhen, this cooling relies on electrically powered refrigeration systems, which makes each cell produced more expensive. In Alaska, the freezing climate itself does this work for almost nothing. Tesla thus replaces a billion-dollar energy bill with a free and clean climate solution, also leveraging the region's geothermal and hydroelectric sources to keep the factory virtually emissions-free. This logic makes Cold Forge not only the most efficient battery factory the company has ever built, but a direct threat to Chinese dominance. With production costs estimated at less than $45 per kilowatt, Tesla now operates with a margin that no lithium-based factory in China can reach. For comparison purposes, major Chinese manufacturers still produce around $131 per kilo. The difference is so stark that it's not just a competitive advantage, it's a death sentence for a production model that was already heavy and expensive. And this change isn't in the future, it's now. The factory is already operating in industrial testing phases and has an accelerated schedule to reach full scale by early 2027. The first Cold Forge packs are already being shipped for validation in Tesla models in Canada, where the harsh climate serves as a natural test bed. All this without relying on a single gram of Chinese raw materials. The entire cycle, from aluminum to the car, is now North American. What's more, it becomes economically irresistible for those who need to cut costs without sacrificing quality. But the biggest impact of this move isn't just in the numbers, it's in the symbolism. For the first time, a Western company is building a battery factory, not to compete with China, but to make China relevant in this sector. It's a silent but relentless disruption that bypasses tariff disputes and ignores trade blocs. While governments debate taxes and agreements, Tesla builds autonomy with steel, ice, and precision engineering. Another detail that sets Cold Forge apart is its scalability. The factory model can be replicated in any region with similar conditions, and studies already point to locations in Canada, Iceland, and Scotland as future targets. Tesla isn't just building a factory, it's creating a modular model. Decentralized battery production, each new unit further reduces dependence on long, unstable, and expensive logistics chains. And this new paradigm has profound implications for the final cost of vehicles. By lowering the price per kilowatt-hour, Tesla can reduce the total production cost of an electric car by up to $10,000. This not only creates a huge advantage over Chinese automakers, but also allows them to increase profits even at a lower price. And, in the industrial world, whoever can make the most profit by selling for less calls the shots. Cold Forge, therefore, is not just a cold factory in the middle of nowhere. It's a turning point, a watershed moment that shows how the future of mobility depends not only on brilliant technological inventions, but also on bold, geographically intelligent industrial strategies. With a revolutionary factory operating outside China's reach and a battery that can outlast the car itself, Tesla isn't just improving its products, it's reshaping the geopolitical energy landscape. For the first time in decades, the United States has a concrete, viable, and measurable path to achieving real energy independence. And it's not in 30 years or when oil runs out, it's now with aluminum, a resource that, unlike lithium, the country has in abundance already explores efficiently and can expand without depending on political rivals or conflict zones. The mathematics of this shift are impressive. The United States holds less than 1% of global lithium reserves, forcing the country to import more than 67% of the necessary materials for your batteries. Aluminum completely changes the scenario, with 1.7 million metric tons produced annually and idle capacity that could grow to 5 million in just 5 years. The country gains control over the raw materials and the entire value chain, not to mention the 1.5 million tons already stored in strategic reserves, idle, waiting to be used. And most amazingly, the impact of this isn't limited to electric vehicles. By eliminating dependence on lithium, cobalt, and nickel, all concentrated in high-voltage regions, the United States shield your defense system, your civilian industry, and your critical infrastructure against international instability. Military satellites, drones, power grids, data centers, all can be powered by aluminum batteries, making the country less vulnerable to global boycotts or sabotage. It's a silent but effective blow to what was once considered a weak point in American national security. This shift also creates a massive window of economic opportunity. By replacing battery imports with a 100% domestic supply chain, the U.S. can save up to $150 billion per year. And this money not only stops coming out, but begins to circulate internally, fueling new factories, startups, research centers, universities, and a chain of local suppliers. The multiplier effect is brutal. For every $1 invested in domestic aluminum battery production, the estimated return to the U.S. economy is as $450, a 450% multiplier that few sectors can achieve. And with so much money circulating, jobs naturally multiply. The most conservative estimate is 400,000 new direct jobs only in the aluminum processing area, others 100,000 in battery manufacturing, and more than 800,000 indirect, linked to logistics, artificial intelligence, maintenance, recycling, engineering, and services. But the most interesting thing is where these jobs will emerge, precisely in the regions most forgotten by industry in recent decades, the so-called Rust Belt, which could now become the new battery belt of the United States. The structure is already there, and aluminum smelting plants ready to be modernized, ports optimized to drain the material, and a 12 top universities that are already researching advanced applications in aluminum-ion batteries. Companies like Alcoa and Reynolds are investing heavily, seeing this movement not just as a trend, but as an inevitability. Tesla was the first to take the plunge, but it won't be the only one. The market is already moving, and this movement has the power to expand far beyond the automotive industry. With its mastery of aluminum battery technology, the United States is at the forefront of the next global energy generation. No longer hostage to oil or Chinese lithium, but now owners of a cleaner, safer, and more sustainable model, completely replicable. From here on, independence is not just energetic. It is industrial, military, and economic. And even though many people haven't realized it yet, this shift has already begun. It's no longer just on paper, nor in promises. It's being molded, welded, and tested, cell by cell, in every battery pack, in every new job. And when cars start rolling off the production lines with this new aluminum soul, it will become clear that this isn't just a technological innovation. It's a global repositioning. As Tesla advances in its energy and industrial independence, the inevitable impact begins to hit those who most depend on the old model. The Chinese automobile industry, China, built its electric vehicle empire based on a simple logic: mass production with lithium batteries, abundant labor,